Okay everyone, my name is Alex Beamer. I am giving my presentation today on disk partitioning using the Fdisk utility from the Linux command line. So, first off, what is disk partitioning? Well, some of you may know this already, and some of you may have done it already. But for those that don't know, disk partitioning is taking your hard disk drive or your solid state drive, whichever you happen to have, and splitting it into many logical storage spaces. Now, each of these storage spaces can be of various sizes, and I will show how that can be done with using Fdisk later. Your disk size can only be as big as the disk. For example, your hard disk comes as one full disk, and if you create another partition, say you have a 500 gigabyte disk and you split it and you make a partition that's 250, you now have two logical partitions on one disk. Now, each one of these units that are split into is what is known as the partition. Reasons why you may want to partition your disk are kind of as follows. There's three main reasons that I ran across amongst my research, and it is that by doing so, you can localize the corruption of files to one partition. Partition of your 250 gig partition, if that one got corrupted, then the corruption would only stay in that particular area of the disk. It wouldn't spread to any of the other parts of the disk, and thus you can set up a backup kind of system with it, since each partition is can be recognized as a drive with its own drive letter by itself. So that way, if you do get corruption on one partition, it does not affect any of the other partitions. And then the other reason is that you can maximize your storage efficiency, and with that, it's kind of nice. For example, if you have you can set the block size of your partition to be what you're going to be, to fit what you're going to be storing on it most efficiently. For example, if you have, say, a 3,000, let's see, your block is of 3,000 bytes or something like that. That's a pretty large block. But you can take your block, you can take whatever you're storing, and you can make the block size to fit it so that you're not wasting a whole lot of extra space storing something that's a lot smaller than the actual block size. For example, if your block size is 512 bytes and everything that you're storing on it is only 8 or 16 bytes, then you're wasting a whole lot of space. And so you can change your partition block size in order to make more sense and be able to store more of your items more efficiently. The third item that I found is that it helps limit your data growth. And what I mean by that is, say for example, well, not even for example, this happens all the time. Every one of us has seen the teenagers and the kids that like to download and install a lot of things to the computer system, and they don't uninstall some things from the system, and so it gets cluttered and full and everything. And so if you want to limit the amount of things they can download to their disk, you can set your specific partition to a certain size, and once that size is reached, then they can't grow anymore. Otherwise they would be running into the other partitions, and because of the way that things are set up, it will not allow that. So you can contain growth to a single 30 gig partition just for somebody else, so that they can only fill that and they can't take over the entire disk space. Alright, so there are, from what I have found, 4 kind of different partition types. There's primary partitions, extended partitions, logical partitions, and swapped partitions. Now, primary partitions are the ones that you deal with the most. Primary partitions actually used to exist as part of the boot sector, and you couldn't do a whole lot with them. But there have been changes, and it is no longer part of the boot sector, and you can do a little bit more to them. One of the things that kind of comes is you can only have 4 primary partitions, and that's it. That's the only thing you can have. Now, some of you may be asking the question, okay, so then how do I have more than 4 partitions? Because if I make 4 partitions of 100 megabytes on my 500 gigabyte drive, then there's a whole lot of space left for me to make partitions. So how come I can only create 4? Well, I'm not really sure. It has to do with some other things, some other reasons way back when. And for those reasons, we can only create 4 primary partitions. However, we can kind of skirt around that, and that's where the next thing, extended partitions, come into play. Now, an extended partition is a primary partition, but the extended partition is the one that can be subdivided into as many logical partitions as you really want it to be parted into. Although every single partition you make sorts after the full disk is a logical partition, the extended partition is where you can make more partitions beyond the 4 primary partitions. The swap partition is a certain partition that is set aside to be used in case you run out of physical RAM. It acts as just an extra RAM space, and it is not utilized unless the system absolutely needs it to be utilized. Now, on Windows, it does a similar thing to this, and on Linux, it does a similar thing to this. You don't necessarily need to have a swap partition if you have enough RAM. For example, if your computer has about 2 gigabytes of RAM, then you will probably want a swap space of at least 1 gigabyte, just to make sure that you have a little bit of extra space to run some things. If your computer probably has 4 gigabytes or more, at least for the average home computer, then you probably will not need a swap space. Now, when you set up a Linux machine, it asks you to make a swap space in the first place, but you can go and get rid of it if you would like to. Alright, so before we go into actually demonstrating how to do this, there are certain naming conventions for the drives, and I've listed a few of them, and it kind of goes like such. You have your you have your main drives, and it depends on how it's connected. IDE drives that are connected via IDE controller are listed as HD, and drives that are connected via SCSI controller are SD. And you can look at these naming conventions that I've written, that I've kind of put down here. SDA, SDA1, SDA2, SDA3, HDA, and HDB2. Now, the first drive in your IDE array will be, or SCSI actually, it'll be both, will be HDA. And in this case, another SDA. And it does that, keeping with the alphabet. It's nice that they do that. If you were to have your second IDE drive would be then HDB. Now the ones behind, the 1, 2, 3 and 1, 2 behind them show the partition for each one. In this case, SDA is the first SCSI connected disk that I have, and SDA1 is the first partition on that disk. SDA2 would be the second partition on disk SDA, and SDA3 would be the third disk partition on SDA. And then the same for HDA1 would be the first partition on HDA, and HDB2 would be the second partition on HDB. Now this comes in handy because when you're going through and you're trying to figure out which disk you're going to partition, you need to know which disk you're going to be working with. And if you know which, this naming convention, it comes in handy to help you know which disk you're going to be working with. Alright, now okay, those are my terms and concept questions. I'll come back to those in a minute. For now, we're going to jump over to my virtual machine that I have here of Ubuntu, and we're going to have to log in here with my password that's so secure it's not even funny. It's the most secure password I've ever used. Alright, so we're going in here and we're going to go into the terminal window. Let's see here. Okay, so terminal. Okay, now the first thing we need to do is identify which disk we're dealing with, whether it's HDA or SDA, depending on how it's connected. Now, since this is a virtual machine, it's plugged into my USB, chances are it'll be SDA. In fact, most of what you're going to run into nowadays of partitioning probably will be SDA due to the SATA connection of most drives nowadays. If you do run into the HDAs, then you're probably working on someone's ancient computer. So to do that, we want to go ls-l of our dev directory. And in our dev directory, it stores a whole lot of fun information. We all know. We've all taken a look at it. And we're going to go and look in this third column here for, actually it'll be the fourth column, it'll be disk. And as we can see, going up here, there's quite a few things labeled disk. And some of these, I'm not sure what loops are. But down here we can see, okay, so we've got SDA. Okay, so SDA, and we've got SDA1, SDA2, and SDA5. Okay, so right here. So SDA is the main disk, SDA1 is the first partition, SDA2 is the second partition, and SDA5 is the fifth partition. And I will explain why it has that funny naming convention in just a minute. So, alright, so now to open the Fdisk utility. The Fdisk utility is opened as root. You have to do this as root. So in this case, you'll be sudo fdisk /dev/sda. Enter, and then it asks you for your password. So simple. Okay, now once you see this prompt right here, you are now in the Fdisk utility. So now we can go ahead and begin partitioning our disk. One thing I want to mention before partitioning a disk, you have to be extremely careful. If you don't do partitioning of your disk correctly, then you could render your disk unusable, and you will have to perform emergency recovery procedures using either a live CD or bootable USB or something to get into a different environment in order to make changes to the disk. And if you don't do it correctly even further, then you could render the disk unusable altogether, destroying it completely. So the nice thing about Fdisk is that you can make changes without actually applying them. And so that's what we're going to be doing. We're going to do a lot of that. So the first thing we're going to do is look at this menu and press M for help, and it brings up the list of commands. As you can see, it's not very powerful. There's not a whole lot to it, but you can do quite a bit within it as well. So, alright, we see P, which will print our partition table, so we'll print this out. Alright, okay, so we see SDA1, and then we can see all the information, and let's see, we've got, up here, it shows we have 21.5 gigabytes total on our SDA, and then 255 heads, 63 sectors, 2610 cylinders, and a total of a whole lot of sectors. Below it we have the units, the units in it, which are the sectors of 1 times 512 bytes. Sector size is 512 bytes, and our IO size is 512 bytes. And the disk identifier in hex. Okay, so what we really want to look at is this place right here. Now this has a whole lot of information for us. Now we can see, okay, SDA1, first partition, we can see that it's been marked as the boot partition. So that is where the system will look to for all of the devices required to boot the system. The SDA2, we can see is not marked, and SDA5 is also not marked, but right here, this is the start and end units, I believe. That's what it is, the start and end units, the number of blocks that partition takes, and this is the ID, which is a hex code, and which system it falls under. Now see, SDA1 is the boot device. It has a start and end location on the disk, the size, the hex ID, and that tells us that it is a Linux file system there. A Linux system there. Now SDA2 is an extended partition with ID 5, and SDA5 is a swap partition. So you may be wondering why this isn't 3. It's kind of funny. Because SDA2 is an extended partition, that means every partition following it will be a logical partition underneath that extended partition. So SDA2 being the extended partition, SDA5 is now a partition within that extended partition. It's kind of interesting that way. You have to keep your thoughts straight on this, otherwise you'll get lost and make some mistakes. Now it jumps to SDA5 because 5 is the first logical partition within an extended partition. So it doesn't matter if SDA1 is the extended, the next partition will be SDA5, and 6, and 7, and so on. So in order to do some other things, the first thing we're going to do is go back to our menu, and we're going to delete partition 5. So you can see that it's taken that effect. It hasn't actually applied this yet. We will not be applying anything because I don't want to break my system. Not that we will, because we're not going to be doing anything that intensive. And we're also going to delete partition 2. So now we've got partition 1 and nothing else, and we've got a bunch of space available to us in order to make a new partition. Now, how to find out that space takes some calculation. In some systems and in other utilities such as gparted, and in Windows it would be disk management, you can see the size available to you from the get-go, and it's done in megabytes and gigabytes and kilobytes, and so you can see what you've got left. Alright, so here we go. So to create a new partition, we're going to type N for new, and it will ask us which partition type we have. Now we have 2 types right now. We have an extended partition. We have a choice to make a primary or an extended. Now an extended partition counts as a primary partition. Nice, here we can see we already have one primary partition. It's right up here, and we have 3 free, so we're going to go ahead and use those 3, but we're going to make them small. So we're going to say P for primary. That's going to be partition number 2. We'll let it start at the default sector, and we're going to specify the size here because if you don't, then it will take up the rest of the disk space automatically. So we're going to say plus, let's do 30, and M for megabytes. So we just created a system device, a partition of size 30 megabytes with starting units at that number and ending units, with starting units at this number and ending units at that number on the disk. So now a question I had is, okay, well, how do you turn it into a swap partition? So you can actually change the type of partition this is. So what we'll do now is we'll change the type of a partition. Before you do that, you can press L, and that will show you the list of every single type of partition you can make. Now we're going to turn this into a swap partition by doing the following. We locate the code that says, okay, 8.2. It is right up here, right next to the Linux identifier. This is the swap partition. So we're going to change that to swap partition. Notice you can change it to anything, literally. You can even change it to, if I remember right, you can change it to DOS in some cases. Like over here, there's DOS, there's GPT, there's a DOS secondary. You can even make some VMware stuff, which is kind of fantastic here. Alright, so we're going to go ahead and change the type of disk on partition 2 to a Linux swap space. So T2 and code 8.2. Okay. Now we've changed that to partition. We've changed partition 2 into a swap space of 30 megabytes. That's not very much swap space. Okay. Alright, so we're going to make one more new primary partition. Again, N for new, P for primary. Partition 3, we'll let it start there, but we're going to make this of size 50 megabytes instead. Okay, and we're going to leave that alone. We're not going to change the type. Now, you may be thinking, okay, how do you... And so now we're going to make an extended partition. So new, extended partition, first sector there, plus... And actually, we're going to let this take up the rest of the disk because you want to have a lot of room for your logical partitions within your extended partition. So we're going to let it go ahead and do that and take the rest of the disk as it has. So now we've got these 4 primary partitions. Now we have to go ahead and create a logical partition. Now you may think, okay, how do you do that? Well, the same way. You press N, and it comes up and tells you, well, all the primary partitions are in use. You already have 4 primary partitions. What are you doing? I mean, okay, okay. So adding logical partition 5. So, and that's the reason why it's always 5, because 1, 2, 3, and 4 are reserved as the primary partition labels. So we'll do partition 5, we'll let it begin there, and we will give this one 100 megabytes. Okay, so now we have a partition 5 of 100 megabytes. Now you can make as many logical partitions as you want up to the size of your extended partition. So if I were to make another new partition of partition 6 and just let it go, then it will take up the rest of the space in partition 5. In our extended partition 4. So we wouldn't be able to make any new ones. In fact, if you try and make a new one, it tells you that there's no free sectors available because they're all being used by partition 5 and 6. They're all being used by the rest of the partitions on the disk. So you can go through and you can delete them. Like we'll do right now, we'll delete partition 6. And you can create another new partition and resize partition 6 to say 500 megabytes. And then that will take up, it doesn't take up the rest of the disk. Okay, so that is disk partitioning. I hope that comes in handy, and this is my presentation. Let's go back. I'm going to press Q because I don't want to write the changes. In fact, if you do want to write the changes, you press W. I'm not going to. I'm press Q, then we'll exit this, and then we'll go out of virtual machine, and I will pull up my slide, which has my terms and definitions on it. Whoops. Okay. Get down to the end here. There we go. Okay. So here's my terms and concept questions. A partition. Define Fdisk. Define a swap partition, because they are 2 different things. And then once you've opened up Fdisk, what commands would be used to create a primary partition of size 30 megabytes? The next, how many primary partitions are you allowed to create? Now the answer to this is 4. You can have 4 primary partitions. And to create a primary partition of size 30 megabytes, the commands are N for new, P for primary, enter using the default beginning sector, and at the next step, plus 30M, no spaces, enter, and that will create a primary partition of size 30 megabytes. If you need to, you can go back and look at my demonstration of how to do that, and you can see for yourself. I hope you don't have any questions, because if you do, well, you may end up asking Dr. Grady those questions. He will have to do some of the answers for you, or you can ask me next time you see me. And that's my presentation.